fall meeting of the Reclamation Advisory Group. So on behalf of Dr. DeSutter and Dr. Meehan, my name is Aaron Osterland. We're going to be diving into all things reclamation and remediation here today. So a brief agenda for what we're going to be getting into. We're going to go through some introductions through the room, as well as the folks online. I'll call you guys out just so that we can get a sense of the representation of the stakeholders here today. Thank you all for participating. We're going to cover a couple updates focused around our outreach and workshops that we've been able to execute here over the last few months since our last update, as well as do a little bit more of a brief overview of the research. So thank you for anyone who participated in the summer online Reclamation Advisory Group meeting. We're definitely very much more focused on research updates, research status, had the opportunity for every one of the graduate students to present where they're at and what they're up to. We're going to be doing a little bit more of a condensed summary in that mostly Tom, Miranda, and I will be updating on kind of made since that meeting. For the folks that weren't able to participate in that summer meeting, that recording was disseminated to the group and is on our YouTube page. And so you can at any point go back and get that update on where we are on our individual research plans. I just checked this morning and 23 of you actually did hop on and utilize that post-meeting opportunity to go through that. So thank you for participating as well as following through and then keeping up with what we got. As we go through any of the outreach and research updates today, or if you get the opportunity to hop in and listen to the recording from the summer, I love getting those phone calls and those emails. I want that feedback. So do the graduate students. So definitely leaning on your guys' perspective and expertise to really guide this ship and really make the research outcomes from what the good work the graduate students are doing meaningful for exactly you people here in the room and online. So once we get through some of those research updates, we're going to dive into kind of next steps for our program. We are going to have an opportunity to go after another supplemental environmental project. So a SEP3, this will be the third round of funding that we can tap into to leverage both the research and extension components that we've been building over the last year and a half. And so we're looking to have a good discussion on the scoping of that phase 3, some of the objectives and goals around it, and then an introduction to what is ultimately going to be a working group focused on that third initiative. And so we felt like we as a group, Tom, Miranda, and I, as well as the graduate students, as we further get down these initiatives for research, we're going to be asking even more of some of you stakeholders that really are engaged in the related fields that we're trying to ask these questions and push the envelope on what is successful remediation and reclamation. And we felt like instead of increasing the frequency of this broader RAG meeting, we would just develop a working group. And so anyone is welcome to join on those working groups, but ultimately what it'll look like is very similar to what we're doing here, just on probably a little higher frequency meetings so that we have a little bit more dialogue guiding some of these specific objectives related to SEP3 as we move forward with that objective. So we'll kind of wrap up with that and have an opportunity for an open floor at the end. I have an entire presentation built today to kind of guide this research, this discussion around research and outreach and future steps. But at any point, I really want you guys to jump in. I don't want this to be just me talking at you guys for the next hour or hour and a half. I'd rather have it be very dialogue. And if we completely get off track, I'm kind of okay with that because you guys have just as much, if not more important things to add to the group as I do, so to speak. So both in person and online, at any point, feel free to unmute yourself and jump in and really get this discussion going. And so with that, I'm going to do just a quick housekeeping so everyone knows that they're in the right room, in the right meeting, and going in the right direction. And then we'll go around the room and do a quick introduction, and then I'll follow up and have the 12 people online introduce themselves as well. And so we represent North Dakota State University. As a university and extension entity, we're interested in a number of initiatives push forward this whole student-focused land grant research university initiative. And what that ultimately looks like in regards to our program, our soil reclamation laboratory, is advancing the research around reclamation best practices. And so that's really the guiding of what we're trying to build our research program around is how can we do what we're already doing better, and even identify opportunities to enhance best practices. We really are interested in developing additional management tools for industry so that the practitioners that are on the landscape doing the work associated with remediation and reclamation associated with energy development have the resources, whether it's education or technical tools, to just be as successful as they can. And that third one is really what we're doing here today, which is creating platforms for collaboration. And so when it comes to energy development in North Dakota, there's a lot of stakeholders from the landowners all the way through industry and the folks like myself in between, or the regulatory folks. We all kind of have a seat at the table and we're all working towards similar goals. And we feel like there's a lot of value to basically get everyone in the same room and just have really good conversations so that we're working together and collaboratively to move this whole thing forward. So what that kind of looks like as far as the Reclamation Advisory Group, everyone here in the room and online, is kind of four unique opportunities that we ask of you guys. So the first one is just engaging in things like the RAG meeting so that we have representation from all of these individual stakeholders engaged in this whole remediation and reclamation ecosystem. And then additionally, identifying environmental risk and resource utilization so that we understand, like right now, we're pretty focused on the impacts of produced water and releases of produced water, but the hydrocarbon thing isn't lost on us. We have a lot of resources and research that we've done in the past related to hydrocarbon remediation. We want to make sure that we continue to identify that as the environmental risk that it is and do our due diligence around research and dissemination of that information. And so as things continue to pop up, we had a discussion before the meeting on the wildfire. And so even opportunities like that, pressing needs of our stakeholders at the present time, there's no reason that we can't utilize the network that we're building within the advisory group to really leverage those things. Not to mention we have really good representation from both the Stockmans and Extension on the work that they are doing specifically around the response effort to those environmental risks. The third one kind of goes into that whole BMP and just environmental strategies, just making sure that when we do identify environmental risk, that we are coming up with those best practices so that we can all do the best job we can. And then that final one is any kind of new research opportunities. We are exceptionally well positioned to be responsive, especially as new things pop up. And so it doesn't always have to be an entire set proposal and a 5-year research plan. Sometimes there's a question that pops up that because we are in the lab and in the greenhouse and in the field, we can help you guys kind of answer what's the solubility of calcium acetate at 75 degrees before I try to amend this impacted field. Things like that are awesome opportunities for us to leverage the resources that we have as a research team to enhance your guys' ability to do a successful remediation and reclamation. And so those are kind of the pillars and the areas that we want to continue to double down on and engage with all of you folks to be successful around the objectives of not only the university, but everyone else engaged in this work. Before we get into outreach and prioritization, let's go around and do some introductions. So I'll start. My name is Aaron Ostland. I'm a research and extension specialist at North Dakota State University. I work 50-50 under Dr. DeSutter and Dr. Miranda Meehan. And I spend about half of my time working with graduate students, working with our faculty to try to leverage our resources at NDSU to really push forward in the work that I just outlined around remediation and reclamation. The other half of it is extension and outreach. And so trying to make sure that we're not just over in Fargo and not interacting and getting this information out into the hands of the stakeholders. And so that looks like organizing things like the Reclamation Advisory Group, but also sitting on the committee for planning the North Dakota Reclamation Conference. which will have some exciting updates here hopefully in the next couple of weeks on the 2025 version of that conference. And then participating in other opportunities, whether it's going to additional conferences or going to field days, just to try to further disseminate the good work that we're doing.
Jason Lisa at Night Farm and Ranch, just 10 miles north of here. And I am the immediate past president of the North Dakota Stockmen's Association.
Miranda Meehan, I'm the Extension Livestock Environmental Stewardship Specialist and the Extension Disaster Education Coordinator at NDSU.
Kathy Johnson, a Farm and Ranch north of Tioga. I said just the other day, we're 11 years and 20 days into our Tesoro oil spill, and it's done. But we're right into another saltwater reclamation, which year 2 of the crop, and the crop didn't fill. So it's kind of constant thing where we're at.
I'm Shane Demando with Select Water Solutions. I'm the director of our disposal and landfill division for the Rocky Mountain region.
I'm Ryan Odenbach, and I just in my second week now working with as the agriculture and natural resource agent in Mackenzie County. I spent the last 6 years working in environmental consulting, I guess, with oil and gas, and then previously to that, I farm and ranch and worked with soil conservation district.
Hi, I'm Ron Webb. I'm the program assistant specialist for the Department of Agriculture that oversees the pipeline reclamation and restoration oversight program, as well as our royalty oversight and our wind reclamation program. Tom Sutter, NDSU, Soil Science.
Gary Hecker, Department of Trust Land, Circle for Reclamation and Right-of-Way Conferences.
Shane Ewert, Environmental Services Manager for Stelt Energy Group.
Amanda Jenkins, one of Reclamation Coordinator.
Brian Kapanek, I'm the Land and Minerals Program Manager for the U.S. Forest Service on grasslands.
Hi, good morning. My name is Beverly, and I am the Urban Soil Scientist for North Dakota, because I am the only one. And also, I am a PhD candidate with Dr. Disorder. So.
I'm going to have the graduate students online introduce themselves, and we'll start with Chantel, please.
Hi, everyone. I'm Chantel Mertz, and I'm a PhD student working underneath Dr. DeSutter, mainly working on produced water spills as well as agricultural salinity.
I'll go.
There you go.
All right, my name is Robert Sam. I'm a graduate student under Dr. DeSutter, and I'm also working on the brine spill remediation.
Tyler?
Hi, this is Saeed Iskandar. I work as an assistant professor at NDSU and have been working with Tom and the NDSU team on electrokinetic remediation of soil.
Hi, I'm Violet Eagle. I'm working on right-of-way compaction alleviation under Tom DeSutter and Miranda Meehan.
Egla and Libby, would you mind introducing yourself?
I'm Libby. I am EGLA's brand new research specialist, so we're just getting our lab started with bioremediation work.
Hi, I'm Eglantina. I'm a recent faculty in the Department of Micro, and I'm going to build a research program on bioremediation.
All right, let's hop in with Cody, then Jason, then Carl.
I'm Cody Vanderbush. I'm the Reclamation Supervisor with Department of Mineral Resources.
Jason Fry, the Environmental Supervisor at the Falkirk Mine. Been doing permitting work, bond release, and reclamation activities here for the last 14 years.
Carl Rockman, I'm the Director of Water Quality with the North Dakota Department of Environmental Quality, and thanks everybody for taking the time to participate today.
I got Nathan and then Mallory. I think it will wrap us up.
Hi, I'm Nate Derby. I'm a research specialist working with Tom DeSutter and the team.
Hi, I'm Mallory. I'm an undergrad at microbiology, and I'm interested in doing a master's degree for Eglintina.
Oh yeah, I don't think I missed anyone, but if I did, speak up. Awesome, thank you guys. Yeah, thank you for participating. Good participation and good representation. That's only going to help us move everything forward. So give me a second.
So I'll just fill in a little bit. So Egla started somewhere in August, so she's been there less than a month-ish, 2 months. So her background is bioremediation of petroleum. She's worked on other organics, and so she's an excellent addition to what we want to achieve with this program as well. So you'll be seeing a lot more of Egla with us.
So we're going to keep moving on to the agenda. I threw this slide in there. You might recognize it. This was the outreach prioritization event that we exercised that we conducted last year when we met prior to the Reclamation Conference. And what really shuffled out of there were, of all of the opportunities that we are still pursuing when it comes to outreach and extension related activities, the three that we're really doubling down on are opportunities for field-based workshops, partnering with industry-supported programs, and continuing to develop what will hopefully result in an NDSU extension reclamation certification or extension program. And so I'm just going to take a little bit of time here to speak of some of the events that we've been able to hold here over the course of the summer and fall. The first one was in relationship to right-of-way education when it comes to cropping systems and basically impacts associated with the installation of pipelines. And so I'm actually going to pass it off to Tom and Amanda to kind of highlight that event and what to and how it went.
So we have always been open about, we're open to providing these opportunities for different groups. And so Amanda coordinated with some of the folks with One Oak, and we had a sort of like an ag soily field day at the Williston Research and Extension Center. And so I'll let Amanda describe what the roles of those folks are. But what we did is we looked at soils, we looked at a pipeline impacts, we looked at sort of the weather station and how NDSU is involved with the Wise Roads part of that. And then Brady, who's in the pit there, he's one of our newer faculty members, replaced Dave Branson, who was our extension soil specialist. And so Brady provided an opportunity for more of a soil profile description, and so the attendees could get a better sense of what soils are. It's not just the top part, but it's like the depth of it. And so, but we think it went really well. I'll let Amanda sort of expound on that.
Yeah, so our right-of-way group reached out, and a lot of our land agents, there's just a disconnect between them and some of the landowners they work with. A lot of these guys don't have any previous farming or ranching experience. They don't necessarily speak the same language. There's been times where I've tried to bridge that gap, but it's not always the easiest. And so I asked Tom, can we put something together to kind of give these agents basic introductory knowledge to this stuff so that they can speak the language when they're going and working with our landowners, and so that they have a better understanding of where those folks are coming from. So we had our right-of-way agents, which are third-party hires, as well as some internal right-of-way folks, go out there, and it was really educational for them to get to see the crops, see the soils, and learn all of that stuff. And it was better well received to them learning that from the university than from the things that I tell them. For whatever reason, and it's very successful, and multiple times I've had our right-of-way group come back to me and say, hey, can we ask NDSU, can we bring them in on this? Can we ask them this question? Absolutely. So it was a really good integration of the two groups, and I think we're going to try to do the same thing next summer. I'd like to expand it and bring our construction coordinators out so that they're kind of seeing the same thing. They're dirt guys, but I think that there's just a more in-depth knowledge they could really get and they really appreciate too. So yeah.
It was a great opportunity to be partnered with the Williston Research Extension facility and faculty folks. They were very well engaging. I think we got to see 9 crops in the field. So awesome to represent the diversity of what cropping systems look like within the region, as well as have the soil pit and really be able to visually identify that topsoil isn't just the depth that the scrapers set at, that these things are very variable across the landscape and between both the soil pit as well as a number of soil cores that we were able to take on site. It really gave that hands-on opportunity to not just hear, but see how these factors influence right-of-way management. So
I will add that, thank you, Stealth, for digging the hole.
yeah, collaborative effort. So by all means, a successful day. And I should probably put pilot in front of that because it very much was like, hey, how's this going to go? Let's learn from this first round and leverage what we learned. It was very successful to the point where we want to engage in additional opportunities to provide these types of education opportunities. And so, again, next summer, looking forward to not only inviting additional right-of-way folks, but kind of expanding scope and then opportunity for other parties and stakeholders to engage in these types of education opportunities on station within the region. Any questions on kind of how this went?
I have yet to see, any time that you dig a pit, a soil pit, and have people there that people don't learn something. That no matter how many years of experience or whatever they have, and looking at a soil profile and explaining what's going on, I have yet to see anybody walk away that didn't learn something.
Totally agree. Had a nice demonstration of segregation of subsoil and topsoil, and yeah, it was a good event. We're looking forward to continuing to have these types of opportunities and provide those opportunities to our stakeholders.
One of the things we also did with this was hard to talk about like the penetration resistance of like roots into dry soil versus soil that has water in it. And so because it was so dry, it was easy to have one guy lean on a penetrometer and, sort of thing. And then we had already staged it such that the soil was moist next to him, and then it went straight down very easily. To talk about the conservation of water and keeping the cover on the soil as opposed to letting it evaporate. So those are the types of things that I think, poke at people or stick with people, I guess. But hopefully, we think it helps. We're open to doing a lot more of these things, and so that's part of what we like to do.
And I think it'd be fun in the future if we could do something rangeland focused. I was there last year. I was on vacation.
Yeah.
In August, so me too.
We crammed a lot into one day, but it was well received and good enough to double down and continue workshops and opportunities like this one. And so many of you guys, you all got the emails, and then many of you guys were able to also hop on. We had a webinar to kick off our PID workshop series. And so for you guys not familiar with PIDs, the photoionization detector is a widely used field instrument for delineation and identification of volatile organic compounds. And so pretty much preaching to the choir for the folks here in the room. I'm sure there's even folks that have more experience than our guest speaker, Justin Blackman, but it was a really good foundation to set for what we hope to be a successful workshop associated with delineation methods utilizing photoionization detectors. And so Justin Blackman was from Ion Science. They produce a pretty popular PID that a lot of you folks actually are utilizing. Through the needs assessment, that was the first step in this process, identified Ion Science as one of those standard industry instruments that are being utilized. And so we were very thankful that they were also willing to extend their expertise in this area. And so we talked about kind of the basics of PID, just how photoionization works, the limitations of the technology, the advancements that have happened in the last 10 years, mostly associated with influence of humidity within the samples that you're taking. And then just briefly got into the proposals around some of the research that we're looking at for enhancing best management practices and SOP, standard operating procedures around utilizing photoionization detectors, which is ultimately where we're hoping to progress this workshop series through. So we're planning additional webinars to help share on the education side to better understand the technology. But the direction that we're really ultimately going is field days and technical trainings. And so opportunities to not only introduce people to how to actually run these things, but having technical workshops around how we can better do headspace development and control some of these environmental factors that contribute to an accurate reading or not. So we're pretty happy with how we started and really looking forward to continue to go down this road of enhancing our ability to effectively delineate hydrocarbon impacts through utilization of this technology. A few of you hopped on. Did it go okay? Looking for feedback. I only got 8 surveys back. Awesome, awesome. Had a pretty wide variety of experience with the participants. I ended up opening up that webinar to our entire mailing list associated with the Reclamation Conference. So it went out to about 1,000 folks. I'm still working on the editing of that webinar, but it'll also be posted hopefully this week yet on our YouTube channel. And so it'll be available for reviewing or watching for the first time here shortly. So continuing to work on that and looking for feedback too. I had the opportunity to discuss this prior to the webinar with Bill Cease, who's traveling today to Denver. And it sounds like one of the first workshops that we're going to try to execute is with their underground storage tank team. So those guys are literally running these things daily. And so we felt like that might be a good pilot workshop for implementing best management practices on technically developing technical skills around operating this thing. And so similar to how we kind of did a soft launch of the field right-of-way soils and cropping systems workshop, that might be a winter or spring soft launch for what will be technical and field-based workshops moving forward with this as well. But open for additional opportunities. So if you guys are working with folks who are interested in learning more or practicing those skills, please don't hesitate to reach out and ask more questions related to the topic. I threw this in there because we did have an opportunity. Tom and I went and spoke with undergraduate engineering course yesterday, about 60 folks that are in mechanical engineering, but specifically the class was product development. And without struggling a little bit to get the research side off the ground on how to further refine PID development. And so trying to leverage the resources that we have in our undergraduate population at NDSU to get the right student in our group to push forward with this development of a more refined PID screening methodology. And so that's my research proposal on the right and the Linktree QR code to our website on the left. It was received fairly well, but yeah, hoping to identify a really good student, ideally from the region that has a perspective on energy development, but has taken thermodynamics and understands physical chemistry and all of those intricate variables that ultimately influence how photoionization detectors operate and respond to volatile organic compounds. So if you have anyone in mind, send them our way. My contact information is right there.
So one of the things was there was no, like I asked the students, is there anybody from Williams, McKenzie County, nobody. And I think and I did tell them, I said, well, maybe we can get you to move there. But I think that's part of our challenge too is, I don't know if NDSU does a well enough job of including this side of the state, because there are lots of opportunities. I just spoke with the high school Ag 2 class here, before I came here. And just to sort of let them know about, right, what opportunities are available. But there's certainly, with Williston offering free courses as an associate, with just working in the industry right away, you know, there's a lot of opportunities. And these kids are fortunate that there are some. But we had a couple of people that were more interested in the soil side. One of them that I need help with Beverly. College. Yeah. So, anyway, that's sort of what we're trying to do, is that workforce development side of things, help in any way that we can.
Yeah, so both the recruiting and then having the resources in place to develop that workforce so that we can continue and even do better at educating folks that can be impactful in the industry that we're working in.
So the other thing that NDSU is doing is they're creating a course called Bison to the Bakken. And it's a kind of a marriage between the College of Business, College of Engineering, and College of Ag. And so basically 13 days, 3-credit class. It'll start like mid-May, and they'll bring students out to this side of the state and actually have the students learn about the industries that are involved, and then how their majors fit into those as well. And so it's open to anybody at NDSU, of course, to take. I did have a conversation with one of the program coordinators and discussed what I felt was like how they should think about this. One of it was like, you know, the upstream, midstream, downstream, how you can hit all of those in North Dakota, but also from the coal side, make sure that because we have a lot of alumni that work in the coal industry, where they could do the extraction part, the reclamation part, but also the combustion part. And that ties in with the engineering and the business side as well. So I didn't give them any names, except for Patty's, because she asked a specific name. But I did, in the back of my head, have this group as a possibility for stops, or at least suggestions. And so bear with me as we move through this process, but I hope that at the end of the day, in May, there'll be lots of opportunities for people to engage. But part of that engagement might be me contacting.
Yeah, hoping to make that a meaningful opportunity for the students to continue to have that connection and this introduction and exposure to what's happening up here.
And part of it is that there's very little activity with NDSU with this side with the oil and gas industry. It's just not very developed. And so where we know that UND has a very strong development with that engineering and so on and so forth, but there is a fair bit of interest from upper administration of developing better relationships.
Along those lines, do you want to talk about a little bit around the development of some future courses?
So there's what's going to be termed the Masters of Ag professional degree. This will be a master's degree. And how soils is fitting into this is we'll be developing some 1-credit courses. See them there. I'll be teaching the soil geography one. And then I did throw out there to add to it a 1-credit course in reclamation. And so it'll be, I haven't heard whether that's on the books yet or not, but that'll be that falls in line with our agreement with Carl and the DEQ to develop a course or courses in reclamation. So,
yeah, these would be components of that certificate or of that program to make sure that we're covering those soil aspects as well as some of the ag opportunities and overlap there. Any questions on some of those initiatives? Some of that is new. The Bison to Bakken thing is definitely new and still coming together. These courses are not live today, but being developed and hopefully offered here soonish.
And they will be all on. There's no in person.
So pieces falling in place, but not necessarily a clear line to the finish yet, but definitely still working on these opportunities for continued education around some of the critical components on what we feel will result in a good reclamation scientist restoration.
So I will add too that I gave a talk at the Ohio State University here a little while ago. And historically, prominently, Ohio State has had strong soil science sort of programs. And I can honestly say, once we hire our soil physics person here, hopefully in the next month, I think NDSU will have the strongest in the country. And so a lot of youth, I'm like literally, I've been there 18 years and I'll be the second senior of all these faculty. We have 5 new faculty and they're all within their first 2-3 years or even months. So I think it's an exciting time for all of us, but I think for the state and their stakeholders, it speaks to our administration supporting agriculture and through that supporting the work that we do as well.
We've kind of touched on a lot of this, but continuing to develop relationships and leverage some of the good work that other folks are doing around basically recruiting and workforce development. And so engaging with, Tom mentioned it, but FFA advisors out here identifying both students and potential future NDSU students on reclamation remediation related work. And so had an opportunity to sponsor an FFA research project associated loosely with soil science remediation opportunities. And that experience was beneficial.
You have to go back slightly. There's SAM 4, actually. So we've had a lot of SAMs or Samanthas in our program. We had Sam 1, who worked at Patty's project over there. Sam 2 worked on Patty's project, and that's Samantha Oster, who's with a youngster. And then Robert Sam is Sam 3, and then Sam 4 is Sam Burchill. And so she was the undergrad that helped us. Or did a project. Now she's in Indianapolis at the National FFA presenting that project. So she's outstanding.
Yep. Hoping to replicate all of the SAMs many times over. And so doubling down on that pipeline of identifying good youth that are capable and interested and giving them the opportunities to leverage that interest and develop good future candidates for replacements of SAMs at some point. Cool. Any questions on this stuff? Otherwise, we'll kind of jump into research and management tools here. The chat, I do have the chat pulled up, so if anyone online doesn't feel like unmuting and just wants to throw in and type in a chat comment, we can work with that as well. Chantel sent me a direct message, so I will read that here in a second. I threw this slide. This should look familiar. We talked at length about this last February, but ultimately this is the Reclamation Suitability Tool. That is one of the layers associated within the web soil survey. This has been an ongoing project on both the development of the tool, but also the dissemination and implementation. Amanda, do you want to talk about kind of like a little bit of integration within your guys' GIS program and where that is maybe today?
Yeah, so we had our GIS folks out of Tulsa put this into our what we call our Redline app, where we go in and we kind of lay out where we think we're going to put a pipeline. So that our construction coordinators and our estimators, as they go through and are looking at those routes, they can say, okay, maybe this isn't the best spot, but we put a pipe here before, so we know that there's going to be some additional costs when we do go to reclaim that. Amanda's going to need more money in her bucket to get this done. And maybe see some avoidance areas as well. So the guys are still kind of playing with that. There's, a million different factors, but it's something that we're actively using to try to pick better routes.
Awesome. Along those lines, we haven't gotten to the point of developing a workshop or a case study, and those were two things that did come out of our larger discussion last February. It hasn't totally fallen off the radar. It is absolutely on our to-do list, but it just hasn't made it to the top yet. And so we're hoping to maybe be a little bit further down that road of having a strong case study to demonstrate kind of how this tool can be implemented for instance, landowners that are being approached by right-of-way project proposals, and how they can kind of use the tool to gather the information to be able to do the same thing, identify sensitive landscapes, and ultimately hopefully avoid those areas that are less susceptible to successful reclamation. I think I got those lined up right. So still live, and we encourage you guys to basically do the same thing I'm doing right here, disseminate this thing, get this thing out into the hands of people that are asking good questions so that they have good information to ask better questions when it comes to the influence and impact of development on the landscape, and how we can better utilize our tools and leverage our large data sets that give us the information to make better decisions. With that, we're gonna kind of shift gears over to the research stuff. So like I highlighted it at the beginning, we did a pretty good job of really getting into the details this summer, and that recording is on the YouTube page. Although it's not publicly available, you will have to use the link that was in the email that I sent to the whole group to access that video recording. If you lost that email, just send me a request, and I can get you that direct link to be able to see that private YouTube recording of the summer research update. But we're going to go through here kind of line by line and just speak briefly on some of the research that has been ongoing since July. So the first one is work that Robert is continuing to do, which is around the calcium acetate. We still feel like this is a really important tool that we can leverage when it comes to remediation of impacted soils, but we really want to understand more holistically what amendments like calcium acetate are doing to our soil properties. And so he's kind of working jointly on things like soil respiration when we're implementing an amendment like calcium acetate, and then working with Egla and her team to try to understand how these amendments might be shifting microbial communities and abundances within soil systems. And so we have a laboratory. We will be running a greenhouse trial this winter, as well as we'll talk about lignite projects specifically after this one, but basically trying to validate and understand these properties for, I must have had the timer on from the Petroleum Council, had rotating slides there, so forgive me for the auto forward on the slides. And so just basically still asking these questions of if we are putting this product on the landscape, how is it influencing these other factors associated with soil, physical, biological, and chemical properties. And so we're still doubling down on all three aspects of the lab, the greenhouse, and the field. And hopefully here, maybe in time for Reclamation Conference, be able to share some of those results as we continue to learn about sequencing of microbial extracts and things that we're really happy to have Egla on the team for.
So then part of that is then with Robert's research, we're trying to better understand, because we know that all these amendments, some of them are quite expensive, like the calcium magnesium acetate or the calcium acetate are quite expensive, where in fact, something like gypsum, which is also a calcium source, is a byproduct from the coal combustion. And so, which is more readily available in the state and fairly inexpensive. But part of that is understanding. So soils are made up of sand, silt, and clay. The clay components is made up of four different illite, chlorite, kaolinite, and smectite. And so when you have soils that are high in smectite, the gypsum will not be soluble enough to really help as much. But, so if we can understand and predict what the percent smectite in these soils are, we can then tailor the amendment and tailor the procedure better that way than if we just decide that calcium acetate is the only thing to use. Because it's very expensive. And a lot of places you won't need that sort of cost. And so Robert's project is basically, we're taking all these soil samples. We have a lot from when Dave Franzen was active. And so trying to model where these and predict based on soil samples that we can send to, for example, to AgVice to have them run 3 things or 4 things that we can then predict what that smectite concentration is. So that's part of it.
So the map on the right is a little old because we were able to collect another 20 or 22 samples from basically the eastern side of the state to try to build that model up a little bit better and represent more soils across the state, so that hopefully we can end up with that predictive model that is useful for practitioners. Kind of the way I try to scope that, if you guys are in the ag and familiar with some of the 4 R's and how we've really developed best management practices around nitrogen management and just like having the right source, having it at the right rate in the right spot. We envision having similar types of recommendations, just understanding how those different amendments are going to interact on the landscape and how we can be most efficient in allocating that resource so that we're not wasting any resources in areas that they might not be impactful, but then also identifying those areas that are susceptible to things like dispersion and getting that calcium on the landscape. Saeed has to run to class, so thanks for joining, Saeed. We'll touch base here shortly. Biopolymers are continuing to be investigated, and we have the primary investigator with us today. And so I'm going to have Beverly give a synopsis of what we're up to.
Okay, well, the idea with the biopolymers is, okay, let me explain you a little bit about this biopolymers. The biopolymers that we are using are derived from microbial biomass, and basically they are polyelectrolyte. Polyelectrolyte means that they have positive and negative charge. So the hypothesis is that the biopolymers that we are using are able to remove not just chloride, but also sodium. So we have been working in soil column experiments to see how is the movement of that biopolymer through the soil profile. And right now we are working in a, how is the name of that facility? The greenhouse. We are working in a greenhouse experiment to see how these biopolymer affects the growing or the germination of some grasses that we typically use in cropping system in the state.
Yeah, so right now we have 2 things that we're like actively working on. One, we're utilizing the growth chamber to look at the impact of these products on germination. And so we're literally taking germination paper, saturating it with these products, putting seeds into contact with that solution and putting it into incubation chambers and just identifying whether or not it's actually impacting germination. Preliminary results say that at a very higher than recommended application rates, it is impacting germination, but at recommended application rates, it's not. And so we've already done barley, oats, sugar beets, AC saltlander, and we're doing alfalfa next. And so the hope is to kind of throw it at a handful of species that are regularly being utilized within either cropping systems or kind of cover cropping opportunities, just to rule out that these products aren't having a detrimental impact on germination, so that we're not causing one problem by trying to fix another. The other thing that will be keeping us busy this winter is in the center picture is 60 pots on a capillary mat within our greenhouse. And so we have a fairly well-developed standard operating procedure for building salty soils. So basically, I'm taking soils, inoculating them with sodium chloride as a pseudo brine impact across a gradient of soil salinities. And then in this case, we were looking at impacts of wheat germination and yield associated with a seed treatment that I can talk about next. But we're going to be replicating that experimental design with her polyelectrical biopolymers to see if they're actually reducing chloride, things like chloride toxicity, and what that ultimately translates into for like yield potential of crops.
Did you mix like sand, clays, silts, as one of your soils, or?
So in the greenhouse, we do trials with clays and a variety of soil textures. We're limited by labor, and so irrigation is always a challenge in greenhouse experiments, especially when you have 200-300 pots that you're trying. So the gold standard would be to water to weight and be very precise with gravimetric water content. We found that that's really difficult with the number of pots and with like heavy clay soils like the valley. And so where we've really landed is that we're still using mineral soil. We're definitely staying away from other greenhouse methods that rely on soilless media. That's basically peat moss. That's what all of our genetics and breeding programs use in greenhouses because it's really easy to manage things like water. But as soil scientists, we're sticking with our tried and true discipline. And so we've landed on using a fine sandy loam from the Oaks area. And so it's a Hecla Hamar soil series. And what we found is that it has really good drainage properties because we're talking an area that is highly irrigated and good production. It has really good P and K and is low, and so we can manage N through our nutrient management in the greenhouse, and it allows us to do these larger replicated studies in a controlled environment. So we're trying
Kind of just a baseline.
Yeah. So it's not a direct representation of like a field assessment where we are on an active brine spill and working with brine impacted soils, but we're trying to basically isolate the influence of the sodium chloride component and then really identify the chloride toxicity, sodium impacts within a controlled environment.
It's more tied to your seeds and plants than it is the soil itself.
Yep. But these are good questions, and we haven't quite mixed this all together yet, and so we're still.
But there are just so many to get into that. Narrow it down.
What we do is we'll do a greenhouse worked and didn't work, and then translate that to a field study.
We'll touch on the lignite stuff, but what we ended up being able to do is we took quite a few soil samples, bulk soil samples from an impacted brine site across an impacted gradient. And I currently have 6 pots of that soil in the greenhouse, and I'm testing germination and trying to just tease out whether or not I can successfully do something with 60 or 300 pots with that soil. So it's something I'm interested in. I'm just not super confident we can execute it with the precision and labor situation that we have. But it's a very valid question on whether or not we're replicating the environments of the questions that we're asking.
Yeah, I mean, future may tell us something different, or define it enough where.
Any questions on biopolymers and kind of where we're at with that, continuing to help Beverly get the resources and help. So I've got an undergraduate that's basically working as hard as she can to help us get all of these questions answered here. Mertz has been doing a fantastic job of also looking at salt tolerance, both in laboratory, greenhouse, and field components. She's got a number of completed studies that have really highlighted opportunities to leverage salt tolerant species when it comes to both the potential for phytoremediation, but just establishment within impacted areas. She's got a great poster that will be going, again, out to Tri-Society and other opportunities for disseminating this information. Do you want to highlight any kind of updates on that, or?
No, I think it's an ongoing, it's just, part of it is actually getting at what the plant is taking up. So that'll be a winter project with Aaron's help, digesting those plant samples to then run for ion speciation. So that'll help us a lot to understand how much, if you can actually bioremediate or phytoremediate with the salt tolerant crops that are plants that we've identified. So.
Yep, leveraging some of the equipment that we were able to get through SEC 1. So microwave digestion, which is a kind of a complete chain, turning a dry plant material into an aqueous solution that I can then analyze on the ICP OES to get cation and anion concentrations. And so we can compare that to the soil samples that were collected at harvest and get at those uptake potentials of kind of where these anions and cations are moving within that soil plant system. Good stuff that we continue to do work on, and yes, I have a very large pile of vegetative samples to be digested and analyzed here. We'll definitely be staying busy on that front. Vegetation establishment and seed recommendations. What I meant by that was getting at both Amanda's research projects as well as Violet's. And so do you want to just give a quick highlight of kind of how the summer went and where we're at on?
Yeah, so we had a super awesome crew that came out and we busted through a bunch of vegetation sampling. So we ran transects and looked to see what kind of vegetation we had growing on and off right away on a couple different pipelines of different ages and different seeding methods, different soil types. And then we also clipped vegetation to weigh what our productivity was. So all that data is in, and now as my fall seeding for my big kid job slows down, we're starting to analyze and look at that data.
Awesome. Violet continues to do both assessments of the soil samples that she collected this summer as part of that kind of overall project of looking at changes on and off right away associated with pipeline installation projects, as well as her laboratory study, which is utilizing a growth chamber in our facilities to kind of get the next step on what Jared Lardy was able to look at, which is this relationship between soil moisture, bulk density, penetration resistance, and how that influences rooting capacity of plants. So you can see that's a soil core on the left where we are actively compacting soils to a penetration or to a bulk density, correlating that with penetration resistance, and then planting crops in there and giving different soil moisture contents to try to get at and observe how the rooting potential of those plants change across those variables. And so insightful in understanding when and where it might be appropriate or where it isn't appropriate to try to reseed when we're looking at say like something like a field measurement of penetration resistance, just to know when we might not be successful in reestablishment because of limiting factors like that.
And certainly it'll highlight eventually the conservation of water in the soil, management. For example, so Amanda's screws that we all now apply straw and pin the straw into the soil, which will conserve water, should increase the rooting ability of seeds, just because you have more water in the soil. So it's challenging in this area because you get so little water and the atmosphere demands so much. So anything we can try to do.
Yeah, two things. This one is, we are looking at 3 different soil types here. And then the same ones Jared had looked at. And then we're looking at oaks and western wheatgrass. We have that native species as well. Once we figure out how to get it to Germany.
Yep. There were many rounds of preliminary trials for that one, but I think we're on to something now. We're getting roots, which is was the goal. So making progress, and Violet's been working really hard on that. I'm hesitant to do anything with roots because it is fairly labor intensive and difficult to then extract those roots in a meaningful manner that enlightens how these systems are responding to these variables. And she's doing a fantastic job through root washing and implementing root scanning softwares that basically will identify root length, fine hair observations, give us all of those characteristics that really tell us how successful it was at establishing the root system.
So did you do a sample within the right of way and then a control outside the right of way for each site, or?
This rooting one isn't actually associated with the right of way stuff. So this is
Mentally, yes.
sure.
Physically, no.
Through the comparison of our controlled bulk densities, we could then compare that to if we do like penetration resistance on and off right away. And so not directly same samples type of thing, but ultimately all trying to answer the same question.
So the idea was, you know, if you know what some of the properties of your soils are, you could then fine tune the seeding species and mixture to best capitalize on those soil properties, as opposed to avoiding seeding sort of thing. Ideally.
So what we've talked about so far are kind of like main thrusts, pretty well developed, like on chapter 4, 5, 6, definitely down the road on a lot of those research projects. These ones are either a little bit preliminary or still trying to get off the ground, but we're still investigating this whole opportunity for chloride recovery, especially within groundwater systems using evaporative wicks. And so the picture on the right is our demo of basically a monitoring well. The idea is, can we throw it in a wicking system of some sort, put in some rudimentally small fans to basically control humidity within that monitoring well, because the wicking potential is ultimately related to how well we can manage the soil or the air moisture within those systems. And so still learning and got data loggers and having this thing run for weeks at a time. But we have like a humidity wick on the left there in the bucket that we're just kind of doing tangible, not really measurable observations. But we have within the system, the bucket system, sensors for humidity and then observing changes in volumetric within the bucket itself. And so ultimately, the vision is can we have a little bit more of a passive system on a groundwater impacted site where somebody shows up, pulls a wicking apparatus of some sort, recovering chlorides that have been precipitated within that material, replacing it and gone again. So fairly easy labor installation, but hopefully a meaningful recovery of contaminants is kind of where we're at on that one. And so still very much in the lab, not necessarily into the next phases of what we hope to continue to investigate in that opportunity. Still working on kind of the manufactured soils and opportunities to highly amend otherwise depleted and disturbed soils through the use of biosolids or some of our other amendments that are available to us here in North Dakota. Still working on that on my side of things, looking at characteristics like water holding capacity and how those amending soils at a high rate, how those are influencing different properties that we're interested in preserving, like soil moisture.
So Aaron's working on his master's with that project. He also just acquired a beautiful young baby boy about how many months ago?
He's 4.5 months.
4.5, who has decided not to sleep much. And
Yeah,
so Aaron's progress in his master's is Arlo is a part of that. So.
Yeah, family comes before technosols. I'm sorry, folks, but we'll get there. I promise. We will get
Masters
there.
in parenting now.
Yeah, it's kind of family, job, masters, and it's been a wild 4 months. I won't change anything, but yeah, that 4 month sleep regression is real. We did get a good update during the summer on our collaborators over in engineering that have been kind of furthering this investigation along electrokinetic potentials and how we can create gradients within impacted groundwater systems to be more effective at recovery of contaminants. And so that little apparatus on the bottom left is a EC chamber. We're able to change sodium chloride concentrations within it and then observe fluxes basically when you're inducing electrokinetic gradients into the system. And where they're really kind of pushing the potential application of a technology as a selective ion selective membranes. And so we have these funky engineered materials that are able to only be permeable to selective ions. And so if we can literally create a material that only lets chloride ions through. So think of it kind of like a reverse osmosis system that is a permeable membrane that only allows water molecules through. These engineered materials can be selective towards a specific ion. So we're trying to investigate the opportunity to kind of implement those systems so that when we create a gradient through electrokinetics, that we can kind of concentrate and isolate those chlorides within a system where we then can extract those chlorides at a higher concentration compared to just going after a non-concentrated impacted system, so to speak. So looking at actually wicking applications. And so in this case, that picture has a little piece of hemp fiber sticking down into the cathode side and assessing not only the change in electrical conductivity of the capillary moisture within that wick, but now the next steps is they're actually extracting that solution and running it on an IC to determine speciation. I'm like, okay, we can move chloride or sodium in one direction or another. We can keep it from going back. How can we then extract that from the system with the hope that this all kind of comes together in a more elaborate and targeted extraction system so that we can recover chlorides from the groundwater impacted system more efficiently.
Is that a physical process or a chemical process?
The selective ion membrane is a physical, it's like that channel, that little hole in the membrane only allows a chloride ion through. Yeah, that's the best I can describe it. Definitely not a material scientist. So
there's a lot of sensors and probes you can buy that are ion selective. And we have one that's chloride as an example that everybody uses. And so basically it's just a molecular sieve. Yeah, it's just creating a size that only certain sized ions can fit through. But they can change it all. They need materials engineers.
Yep. So the thought is there might be an opportunity here to leverage this type of technology in like an extraction well or a recovery well on an impacted site or something like that. Still pretty preliminary. Got a graduate student working on it and running lots of experiments like that one with little control chambers just to better understand how things move and why and why it. The XRF opportunity, and so I touched base on this just a little bit last year, and it's kind of come to fruition a little bit here. I have preliminary data, but I didn't throw any of that in here because statistical methods of multivariate regression isn't necessarily something I can do with my eyes closed, and so we're getting close to saying how effective X-ray fluorescence instruments are at determining concentrations of both chloride and bromide within soil systems. So the idea is that in the last 15, 20 years, what used to be the size of a table is now the size of a laptop, in that you can have a X-ray fluorescent analyzer on your tailgate, so to speak. And so the way this technology roughly works is you shoot an X-ray at your media. What bounces off is this fluorescence. We can measure that wavelength and we can correlate that to different concentrations within that material. Our question is, can we shoot a soil and determine chloride and bromide concentrations within that soil from what comes off of it? The way we're kind of assessing that is we had roughly 18 soils from brine impact sites that we collected. I sent all of those soils off to the company that manufactures this X-ray fluorescent machine. They actually make two. One is kind of like a closed system where you do a little bit more preparation of that soil sample and then put it in for the analysis. And the other one is kind of a point and shoot. And so it's almost like a handheld gun, so to speak, and it's widely used for emergency response. So that in a spill instance of a hazardous material, first responders can walk in and basically identify a handful of hazardous materials by just pointing and shooting. Our question is, well, can I run that on a spill site for delineation? Can I walk across this site and in real time determine I have bromide, I have bromide, I have bromide, I have no bromide? And then be more effective in delineation in real time so that we can then allocate resources more effectively in not only kind of containing spills, but also then first response for remediation and reclamation of those things. The preliminary data, without getting myself too far down to where I can't reel back, is that there is a correlation there. It is responding similar to what is our reference method, which is me taking those same soils, doing a 2-to-1 extract, so 2 parts of water, 1 part soil, shaking those things around, and then removing that water and analyzing it on the ICP. And so I have an extractable chloride and an extractable bromide concentration, and now I'm looking at how does that correlate with what the instrument is giving me. I would say that it's probably not as easy as just walking out and pointing and shooting. There is going to be a need, just like any instrument, through calibration and correlation and understanding of the physical properties in the environment. So soil texture, soil moisture are looking like they're probably influential on how well that instrument is at determining chloride and bromide concentration. But it's not so scatter plotted that I'm giving up yet. I think that there is an opportunity here to leverage this technology to have more tools for delineation of specifically chloride and bromide concentrations. Those instruments are roughly $30,000, so it's not trivial, but also if it gives you an opportunity to make real-time management decisions compared to taking a soil sample, sending that to the lab, having them go through the extraction process and analysis and having that take a week or 2 weeks. We feel like there's quite a bit of value in downtime and mobilization costs for companies to be able to have tools in the field to make those decisions more real time. My spiel on XRF technology right now, but continuing to ask questions like that. And maybe something that I can talk about at the conference. We'll see how far I get down the statistical analysis and whether or not 18 samples were enough to actually say anything meaningful or not, is kind of where my questions are at the moment. The very last one of kind of like less developed research questions is that we were approached by a company based out of Denmark who had identified this material, this compound known as butyric acid. It ultimately is a metabolite of a soil microbe that they're able to isolate. They had preliminary research coming out of Europe that suggested that when plants are exposed to this, what is kind of in the category of biostimulant, it results in them having higher salinity tolerance, was what the initial research showed. The initial research came out of hydroponic systems where they're very interested in, can we have a saltier hydroponic solution, which is ultimately just a higher fertility to grow a bigger tomato faster. Well, if you push it too high of BC, too high of parts per million within that hydroponic solution, you end up hitting salt tolerance of plants and you end up going backwards with yield. The research showed that by exposing those plants to this biostimulant, they were able to have higher salt tolerance and ultimately respond with a beneficial yield response to the fertility management in these greenhouse systems. So we said, well, hey, why not? Let's see if it does anything to induce a salinity tolerance within a salt impacted mineral soil. Very different environments. Didn't know if anything would stick. That is the picture of the greenhouse with that trial. I'm working on my last piece of data, which is the final salt concentrations after growing wheat to maturity. And so I had a salinity gradient all the way from, I did percent mass sodium chloride versus dry soil mass. So it was a 0, 0.15, 0.3, 0.6, and a 1.2% sodium chloride by mass. Nothing grew at that 1.2. That's kind of like smoking hot. You ever found a plant that grew in that, been around to something, but we treated, we had a control, had kind of a low seed treatment, so a low rate of this butyric acid, which was in the parts per billion range, which really had us questioning, like, there's no way this is gonna work. This is so low concentration, and then a higher treatment rate. And initially, there wasn't any statistical significance in emergence and germination, but there seemed to be a little bit of a trend in that as we got to a higher salinity within the soil, germination did change its trajectory, in that we were having a slight increase in number of plants per pot, but nothing came out statistically significant. Still working on the statistics for both above ground biomass and yield of the wheat crop. And so pending results, basically. Nothing came out like, wow, this is the next thing that's going to change how we try to grow crops in salt impacted soils. But there might still be research questions worthy of continuing to explore these opportunities around biostimulants and how they induce different physiological responses within plants. That's kind of where we're at with that one. Questions on those ones? I mean, we're kind of throwing a lot out there and then asking lots of questions. We're thankful to have good graduate students that keep pushing the boundaries there. I shared this slide during our summer discussion, but we have been able to work with an awesome undergraduate research assistant named Sophia. She has been helping with Beverly's and Chantel's research projects almost every day, every week. She's an awesome asset. We're really sad that she's graduating and not staying on for a master's, but she's on to better and bigger things. In her spare time, I've been having her mine the spill report database through DEQ, just so that we can kind of keep a finger on the pulse of how many spills are happening, both on a quantity and frequency of spills. And so we have the full data set analyzed from 21, 22, and 23, and she's continuing to update our database for 24, just so that we can continue to understand the impacts of spills, where they're happening and how big. And so we got in this one, this is just frequency over that 3-year period. We're still looking at roughly 1 produced water release a day. And then the quantity side of things is we still have many more on-pad spills than off-pad spills, but the off-pad spills are still representing a larger volume of released product. Nothing really new here. I think we all kind of understand the situation we're in, and it ultimately is the justification for kind of everything we're doing. This issue isn't going away. We've gotten better, obviously, but it still represents environmental risk. So that's what I keep that in there, and I'm thankful for undergraduate research assistants like Sophia, who are willing to do lots of data entry to give us this information. I do want to do a quick kind of recap of one of our field experiments that we had an awesome opportunity to collaborate with our stakeholders in working with both Stealth as well as Steel Reef, which was an active brine spill in the Lignite, North Dakota area. And what we were looking at for our investigation this past year at this site were twofold. One, we were looking at trying to identify any changes in salinity tolerance of some of our commodity and cover crops, which we've already completed through Mertz's work in natural salinity systems in central North Dakota. we kind of wanted to see, do those properties and tolerances change on a brine spill? And so we planted a bunch of crops out there. The other one was, excuse me, starting to implement into the field some of these other amendments that we've been working with. And so the calcium acetate made it into the list, but as calcium magnesium acetate, because calcium magnesium acetate is widely used as a road salt amendment on the East Coast and Central states. And so it's a lot cheaper and easier to get our hands on. And then also assessing the biopolymers that Beverly's been doing a bunch of characterization work on. And then we threw in there and kind of an organic amendment of it was roughly a 50-50 compost and biochar, just to have like carbon sources, because we're introducing carbon sources through these other amendments. And so just trying to kind of see what the response on an active brine spill site is to these amendments that we've been doing quite a bit of work with within the lab and the greenhouse. And so we had a successful season in that we did plant the crops. We were able to do observational as well as soil sampling throughout the growing season, and we completed our fall harvest. And so all of the sampling on this site has been completed, but we have a whole mountain of sample analysis to complete here this winter. And so it'll be a number of analyzing soil samples for the bigger question is microbial response. And so we're really leaning into the expertise and analytical capacity of Eglatina's group in identifying microbial diversity and abundance within these amended systems to try to see, like, in the case of calcium acetate, we are after the calcium because it's a highly soluble form of us getting calcium onto the landscape, but that acetate is a simple sugar, to put it simply. It's an easy carbon source, and we want to understand how are the microbes responding to that acetate within the system. Is it shifting things from one community to the next? Is it increasing or decreasing abundance? Those are the kind of questions. And we're thankful for their capacity and willingness to join the team, because sequencing and that type of stuff is just outside of the scope of our laboratory. And we're really excited about those questions. And it'll take a little bit of effort here this winter, but we're starting to analyze both those soil things, but then also we took biomass samples of what we were able to get growing out there, which unfortunately was quite limiting. Without having data and definitive results, there's more contributing to plant establishment than just brine or just salt content. And so there's definitely something going on with crusting at that site, and that had a pretty observable impact on crop establishment. In that, just looking at the site and looking at our electrical conductivity gradient, it didn't really show how that crop responded. And so we're asking more questions.
Is this a legacy spill or a new one?
Officially, where we came in was the spill was reported in 2019, and it came from a otherwise abandoned disposal well that was on the adjacent site. Right. And so a portion of that release migrated offsite, and we are only doing the investigation in the offsite.
And this is all in situ remediation?
Yep, there hasn't been any meaningful removal. I'm still working through what has all happened out there, because based on some observations that we had through sampling, it seems like there was maybe some scraping that happened as a response, and so topsoil is very more variable than makes sense to what I understand about the site.
And did you do soil test, deep soil test, or how?
We really didn't go any more than a foot on what we did, but Stealth has been doing. Yep. So Sam and
50%.
Yep. So deeper sampling as well as groundwater, which is only about 8 feet there, and there are groundwater impacts, and there are natural salinity in the area, probably some legacy components, and so it's quite the layered system, which is, adding to
Just
the,
that shallow water table
yeah,
causes its own issues.
yeah. So questions for sure, yeah.
Did it plug, fault? Faulty?
I actually don't think I have any details that would enlighten more than, happened in 2019. It was estimated that 200 barrels went off site, so 200 barrels impacting this area.
Plugged.
It was supposed to be an abandoned disposal well. And, it was a really.
What did you use for amendments on this?
Yep, so the amendments were calcium magnesium acetate. And these were all individual replicated plots. We had two of the biopolymers, so the polyelectrolyte biopolymers were two. And then the fourth one was a off-the-shelf, widely available mixture of compost and biochar mixture. So it's that particular amendment is marketed to gardeners, but we just thought, like, we're trying to ultimately understand how these carbon sources are influencing soil response, and so we wanted something that's like a little less, little more mainstream type of application.
Hey, Aaron.
Unfortunately, yep.
Sorry, I have a question too. I'm wondering
Okay,
if sorry, I can hear myself. I'm wondering if the plots are marked out there, just because we're gonna go visit.
Yeah, the plots are no longer marked. When we did our final collection as a courteous to the site managers, we pulled all of our flags. However, I have everything GPSed. And so I could send you out with a iPad with all of that information as a viewable layer. And I can get you within about 1.5 feet of every corner.
Those are all the samples that Robert had already taken.
Yeah, Libby, we already have all of those. So those samples were taken at day 0, day 7, day 14, day 28, day 40 something, and then at harvest. And so we have a full soil series collection across the growing season for every one of those replicants.
Okay, sounds good. We're just looking for metadata for any new samples that we collect.
Yeah, if you can help us get through Robert's freezer samples, that's going to be a lot of data. So like you all know, it's challenging to do research on active managed brine spill sites. We did our best, but definitely faced a number of challenges, and the establishment specifically of plants across the site was evident. We didn't get anything to grow in our amended blocked area. It might have been a combination of me identifying where on that salinity gradient we applied to these amendments and being a little bit too hopeful that we move the needle in a higher impacted area. But I actually am more convinced that things like soil crusting or variability in topsoil are influencing the responses that we saw rather than salinity, because I took those same soils, dried them, ground them, put them in a pot and planted them in my greenhouse, and I got things to grow across almost the entire gradient. So more questions, unfortunately, than answers at this point. But we have many samples that we took throughout the growing season as well as harvest that will take us a while to process through, and hoping to still be able to glean some useful information on what those limiting factors are and how that can influence recommendations moving forward.
I was curious to this site. Soil
Absolutely. Yeah, so I don't know if I'm going to try to challenge my computer to pull up that right now, but
Demo area
that
flat
flat and silly.
and there's plenty of kind of prairie potholes with salty rims.
with wicking around.
Yeah. And so that makes it even a little bit more confusing as far as responses to amendments and plant responses to salinity, and that there's this legacy component, there is an active brine spill, there is groundwater contamination, there is natural salinity, chlorides are prevalent, and so teasing out what that limiting factor is challenging at the moment. But
And it looks like there's crops in spots, and then you have kochia coming, so, you know, some of that's right on the verge of being able to grow something, you know, but, those things.
yeah, and along the kochia, man, the kochia does good out there. We ended up having to do some pretty aggressive herbicide applications in order to try to limit the competition with our crops that we planted with the kochia. That might have been an additional factor that is contributing to the response that we saw.
I would venture to guess that if you went a mile radius around that, you would find other portions of that field that are unimpacted that don't look a lot different than that picture right there.
You're not wrong. And so we're super thankful for opportunities to collaborate with our circle of stakeholders. Steel Reef gave us full access to this site. We've been able to work with Stealth to get these projects implemented. But ultimately, when it comes to like research objectives, it's challenging, definitely challenging. And it ultimately is kind of pushing us towards maybe a different direction which we'll get to next, how we want to structure our field components of our research moving forward. In an effort to not have this be like any kind of a loss, so to speak, we collected bulk soil samples across all of the gradient here, enough to basically replicate all of our amendment trials in the greenhouse. So preliminarily trying that right now with the hopes that this winter we will actually be able to do the exact same experimental design, but in the greenhouse, and be able to overcome or limit the influence of some of these other factors like variable topsoil or crusting potential, because I can physically overcome that limiting factor within the greenhouse a little bit easier than driving 7.5 hours from the main station to like go, oh, shoot, nothing can. That's where we're at. These are good questions. These are things that we've definitely been having ongoing discussions, and we're hoping to continue to answer these things, because it's not just our struggle. This is every remediation site
there's a lot of scenarios that you can take the exact same picture in a lot of places.
Yeah, so one of the big questions that's coming out is potentially building another research project around being able to identify where soil crusting is going to be an issue and what we can do about it. Those are just 10,000 level discussions that when Tom and I have 15 hours in the car together, we start brainstorming, and it hasn't really left that, but anything from throwing dog food out there because it can just soak and absorb and expand, to breaking crusting, to physical disturbance, to looking at specifically crops' abilities to overcome crusting. All of those things are kind of on the table, like this is a factor is limiting success of seeding projects. Is it worth allocating resources to? Are there enough questions that we don't have answered to implement better management practices? And that's kind of where we're at on this one.
Did you do an initial pH on this?
I do have that data. Off the top of my head, nothing. Yeah, no, I don't have that.
Well, just in general, you know, we're seeing more and more cropping systems, you know, where the pH keeps going down, you know, and we're never used to that, you know, but it looks like it's having some challenges as far as getting, you know, like new CRP or new grass growth, you know, in cropping systems, you know. But
yeah, it's
historical.
Yeah, too bad Chris Augustine with the Dickinson REC has done quite a bit of work in the last 1.5 years on that question specifically, not related to reclamation, but related to agronomic practices, because it seems like that issue is maybe becoming a limiting factor in that region specifically. So we are not yeah, you're onto something there. We're asking those questions and doing active research to identify where that's an impact, influence on production. Okay, that is what we've been up to. The next topic is kind of where we want to go, which is a discussion around this opportunity for SEP3 funding. And so the same two sources that have gotten us the funding to get us to where we are today, there's a third opportunity there that we're going after. And we are here to get your guys' input and feedback on exactly what I outlined at the very beginning of the meeting, at identifying environmental risk, allocating resources to those risks, and having meaningful research to answer the questions that we all have associated with successful remediation and reclamation. And so through SEP3, we want to continue to build opportunities to enhance our field components of getting our research on the landscape, and because we have successfully built our infrastructure to do good lab and greenhouse work, but not satisfied with our success in lignite and wanting to continue to invest in getting all of our research implemented on the landscape. And where we're kind of ultimate goals and where we want to position our research and extension program is going towards this idea of a closed cycle or waste elimination associated with energy development in North Dakota. We feel like through the really good work of the folks in this room and online, we have the knowledge and technology and best practices to really make a meaningful impact on the industry, on its overall environmental impact. And what we're ultimately looking at, this is a lot of jargon to basically say, can we remediate soils to a point where they can be put back on the landscape and we can regain soil function? There are a lot of logistical challenges and research implication questions, the same ones that pop up at lignite and every other site, that we're hopeful to identify systems that we can control those factors a little bit more. And then on top of that, we have 9 hazardous waste disposal facilities in North Dakota that have been accumulating impacted soils for a couple decades at this point. And as soil scientists, we look at that as an opportunity and not an eyesore or something to turn our backs on. That is a resource that we feel like we should be positioning ourselves to try to tackle, not only not sending things to a forever landfill, but potentially recovering those resources for the ultimate good of our natural resources and landscape management in North Dakota.
Prime topsoil went into those piles.
Right. And so because this is such a multi-layered initiative to implement field scaled research towards this goal of soil recycling and soil fully remediated soil resources, we're not naive to, we're like, we can't do this alone. We need collaboration and opportunities to ask these questions, implement the research, and really move this whole idea of soil recycling and soil washing and thermal desorption and soil resource recovery forward. And so to that end, we've been able to have 2 or 3 preliminary meetings with Shane DeMondo with Select Water, as well as having Bill Cease and Stealth Group kind of there to help keep bumpers on our grand plans, to see if we can build research opportunities associated with these special waste disposal facilities to do research there. And so the idea is that it's really challenging to be on an active remediation spill site and do controlled research. Can we bring those soils that are already ultimately coming to these facilities and conduct research at the landfill itself? And Shane has been more than willing to open his doors and provide resources to build that collaboration. And we're really excited about that opportunity, and we want to move forward with that opportunity with the SEP funding that we have available to us. And so I got a couple pictures of two of Select Water's facilities. One is just west of here, south of Arnegard, and the other one is northwest of here at their Dishon site.
Wonder if it's French.
Yeah. Just so about 15 or 20 miles west of Williston. And so where we're looking at is this is an awesome opportunity to look at the unique geography differences in soil properties south and north of the river. And an opportunity to kind of get 2 site years and additional data sets when we're doing this type of research, so that we can have meaningful data to do meaningful interpretations.
Question for you. When these soils come into the landfills, and do you segregate from like drill cuttings versus the soil versus contaminated soil, or do that all get mixed into the same?
It all gets mixed right now. Yeah,
That's a problem, I guess. But-
yeah. I think that can be a control
Right.
thing. It's just, there wasn't really much of a reason
Right.
to separate it.
Right,
But
exactly.
with these efforts, I think it'd be fairly easy to do.
Right.
You are right on line. That is my first bullet point in the logistical challenges, is that the first step in remediating something is delineation, segregation, and understanding where the impacts are. Logistically, it is a challenge, but I don't think it's a challenge that can't be overcome, because we do have, with a hazardous material, the requirements of manifesting every single load when it goes out on the road. And so it might be a challenge to ask a scale operator to be the one delineating those things, and we might have to implement a little bit more of a robust process. But I want to have that discussion, and I kind of want to have that discussion right now.
And it's, yeah, and it's not necessarily the drill cuttings itself, you know, it's the diesel fuel or the additives, you know, that go into that. There's ways to do it. I mean, it just takes money, you know, to pull that back apart.
So before I let you, I want to dive into all of these things, but I recognized, and we recognized that these types of questions are fairly detailed and will take some nuance and take some experience to really have perspectives that we do have in this room to iron out how to approach those logistical challenges and how to develop a research program around those challenges. And I don't want to put that on everyone's in this working group's plate. And that was the whole idea behind development of this working group, is that we're going to probably need to be meeting on a more frequent basis. And I have lunch for folks that want to stick around and participate in that working group. But at this point, we're going to wrap up the formal RAG meeting. And we're gonna kind of transition here this afternoon. I have this room booked until 3 o'clock. I don't plan on keeping you all till 3, but I'm willing to stay as long as you are to work through these specific challenges and questions, so that over the next roughly 9 months that I have to iron out and finalize a research proposal to go after this funding, that we've really asked all of these questions, developed the relationships, figured out how to logistically implement research at these facilities, and identify those opportunities fully, so that when we get this funding, we can hopefully hit the ground running and make it a really meaningful research project longer term. Not just a 1-year field observation to an amendment program, but can we observe these soil properties over 3 to 5 years, and can we really go after this recovery of soil resources question? So with that, I'm going to say thank you to everyone online for participating. many of you hung in there for the whole hour and 45 minutes. I appreciate that. And then also thank you guys for here in the room. I did record today's meeting, and so I will handle it the same as the summer meeting, and that I'll edit it up a little bit on the front and back end, publish that as a private recording on YouTube, and make that available to the members within the RAG group. So if you wanted to go back, for anyone who either missed today's meeting or wants to go back and hear a little bit more about what we talked about, that will come out here in probably the next couple weeks as they're recording. But before I totally wrap it up, because I did technically have you for 14 more minutes, open floor for any kind of questions, any concerns. Does anyone want out? Does anyone have any additional stakeholders that they want to bring in? Right now, my mailing list is about 54, which I'm super happy with, but it's not a closed group. I'm interested in more perspectives and more collaboration. So if anyone has somebody like, hey, Ryan just started, super awesome to bring in his expertise and have local resources within our system. We're looking for more folks always. And so with that, I'll kind of be quiet here for a few minutes and at the floor.
Aaron, Cody Vanderbush here. We've been doing a lot with Terracon and these historic evaporation pits and laying drain tile and stuff like that, trying to flush the salts out of the soil. Would that be of interest to the group to bring them in and visit about what they've done and what they've learned?
I have been working with John. I'm blanking on John's last name. Ellenson. Yep. So he was open enough to come to last year's Reclamation conference and actually speak on some of the applications that they're doing to like implementing capillary breaks, trying to isolate contaminants that are left in place so that they're not recontaminating to resources that are being brought back onto the landscape. I think that is a valid approach, and that some of the aspects that they're implementing in kind of a quick turn of a dig, haul, replace, and get back into production have a lot of value, especially within agronomic systems. I'm not opposed to that at all. He definitely has a whole lot of experience and expertise, and so I will reach out to John. I appreciate that suggestion, and we'll see if he wants to come on board for the working group.
We did connect with the new reporter from McKinsey Farmer. I reached out to her, and she did advertise this meeting within the paper, and so we have thought about offering to do like a reclamation minute kind of thing, where we could publish it in the paper, and if other people want to pick it up, that's so be it. But I think part of, so I get the paper weekly, and part of it is so to better understand not only the community, but also the rural economy around. So, which then led me to, be over at the school here this morning and speak with those students. So we're actively engaged. We are open to opportunities for engaged as well.
Thoughts on this whole, when we started this was, would it be possible to eventually wind up with like a little short course of, like for one of folks coming in that do pipeline work or whatever, and have those kind of go through that short course, that are actively engaged in, the dirt guys, the construction guys, pipeline folks, something that's available to industry, that they can go through. Like I kind of thought of that as you looked at the ND train, what they did with the safety side of things, it kind of makes it's almost standard now for companies to put their folks through some of that. But you could kind of gear it towards those that deal with, working either well pads or sites or pipelines, those type of things.
Certified crop advisor program, certified pipeline.
Something, just a kind of a short covered soils, all these basic things about vegetation, soils, just for folks that they kind of hone in on or clue in on when they're out in the field, when they're doing this type of stuff. You could make it to land people all the way through the reclamation side.
It'd be a huge benefit to everything we're trying to achieve here, to educate everybody from the bottom.
Just be the basics, just so people have the basics, because like you were talking about, a lot of people don't have either like an ag background or any, dealing with that type of background that come in and work on these projects.
I think I could ask, does the Department of Ag have a program? Or within your pipeline authority, is there any of that educational stuff? Not to the extent of this sort of thing, but I mean, the education's all about.
Skills center right across the street is an excellent opportunity to have some of that.
I'm working with them. My email frequency has been really low. So that's on me. We're still working on that relationship, and I think that there would be an opportunity for a course over there. And right in line with their vision and opportunities, and that would potentially open up this opportunity for recruiting and workforce development to they have the facility, they have the recruiting infrastructure already. So lots of opportunity there.
We train them for running heavy equipment, we train them for driving trucks. We can train them for this too.
Yeah, it would be certainly easier to work under an umbrella of something like that, that's already well established and well funded and well supported.
Especially if I can educate the educator, that would make our impact much more. I can only get in front of so many people. They have their loads and responsibilities, but if I can get in front of training 5 other people that then can execute it, the impact would grow exponentially. So there's lots of opportunity
I
there.
think that's one of our ultimate goals, is to have more people that can provide the support to train other people, just because it's very big to us.
It's good stuff. Keep it coming online. There's a few of you hanging in there. Of the folks online, is there anyone interested in sticking on for the next couple hours to have this discussion around SEP 3? Otherwise, if there isn't, I might actually shut that down. Carl, I'd love you to stay on, but I know your time is valuable as well, so I don't want to not recognize that. Robert says, can I leave? Yes, yes, Robert, we can leave. Thank you, Chris, for hopping on. Some of the pH work came up as a question, and so we might have to ask some more questions to your team of research over there. Carl, thank you for hopping on. I appreciate it. Cody and Jason, thanks for hanging in there. Egla, how you feeling? You got teaching responsibilities this afternoon, or you want to stick in there?
I can stay for like an hour.
Okay, I'll keep it going then. Otherwise, 11:55, folks. We're gonna wrap this up. I really thank you guys for your engagement.